And now we're going to apply this to exponential change. So if you want to, exponential change is usually written like this. The amount as a function of time is equal to the initial amount, E naught, times 1 plus the rate of growth or decay, whatever it is, divided by k, which is usually how many times per year that we're going to either increase or decrease, raised to the kt, where t usually represents the time in years. And so now if I differentiate this, there's some interesting things that takes place. So I'm gonna show you how we would do that. So example number 2 says, suppose you deposit $800 into an account, and it pays 6.3% interest rate, and it's an annual interest rate. And after 8 years, how much money will you have in the account? And then it asks you if it's compounded continuously and then compounded quarterly. So the first thing that I'm going to do is I'm going to do continuously. And this isn't so much calculus as it is kind of review, but we will talk about calculus. So then I have the initial amount, which is $800, right? How did I put a percentage there? I shouldn't have done that. $800. The rate, we write that as a decimal, so it's actually 0.063, right, when we convert that to a decimal. And then, that's pretty much it. If it's compounded, let me do quarterly, not continuously. It says continuous and quarterly. So I'm going to do the quarterly one first. So quarterly means that it's going to be done 4 times a year, so that's my K. And then 8 years is 8. So now if I want to figure out what that amount is as a function of time, then I'm going to say 800, right, times 1 plus the rate, which is 0.063, all over 4, because we do that 4 times a year, and then raise it to 4 times 8, because you're actually compounding the interest 32 times. 4 times a year for 8 years. And if I crank through and plug that in my calculator, I'll get the amount that I'll have after 8 years is going to equal $1,319.07. Okay? Now, that was the quarterly. So let's do, I don't know, quarterly, something, we'll circle it. Now, if I were to do that continuously, the formula looks a little differently. The formula is actually A as a function of t is equal to A naught times e to the RT. So if we do it continuously, we eliminate this 4 and 8 stuff. Well, not the 8. It's still going to be 8 times. So same variables, except now the formula is a little different. So I'm going to say 800 times e, which is Euler's number, 2.72 roughly, times the rate, which is 0.063, times 8 years. Now, if I plug that in my calculator, I'm going to get $1,324.26. So that is just kind of the basic